Hello everyone, welcome again to CIA Revision. In this video, we're going to be looking at paper 1-2 from the October-November 2025 series for Pure Mathematics 1 at AS level. And so let's start. The first question is saying express 9x squared minus 36x plus 8 in the form p in bracket x plus q squared plus r, where p, q, and r are constants. And as you can see, this is the completed square form. So we're just going to complete the square for this. And in completing the square for this, where we have a number that's not 1 as a coefficient of x squared, we factor it out. So this will be 9x squared minus 4x plus 8 over 9, like this. And now we complete the square for this part. And so this would be x, and half of this minus 2 squared plus this 8 over 9 minus this squared, which is 2 squared, which gives us 4. And all this is going to be multiplied by 9. Now simplifying that part, 8 over 9 minus 4, I'm getting minus 28 over 9. So this will be 9 square brackets x minus 2 squared plus 8 over 9. Oops, this is the part that I've just simplified to minus 28 over 9. Now multiplying everything by the 9, we get 9x minus 2 squared minus 28. And this will be our answer for 2 marks. Then part B says, hence find the set of values of the constant k for which the equation 9x squared minus 36 plus 8 equals k has no real roots. So in other words, the question is asking us to find the set of values for which this graph does not intersect with that. So looking at this, we have two graphs actually. This is y is equal to 9x squared minus 36x plus 8, and y is equal to k, right? So we want a set of values of k for which these two do not intersect. And for that, if we look at this, they said hence, meaning we are going to use our answer from the previous question. If we try to get the graph, it is a positive coefficient of x squared, so it looks like this, right? And for the minimum point, it's, let me try and draw it more accurately, like this. The minimum point is positive this, which is, I think the first one was better, 2 and minus 28. So this is the minimum point, right? 2 and minus 28. So saying this point is 2 and minus 28. And y equals k is a horizontal line. And for us to draw a horizontal line that does not cross this graph, it has to be less than the y point, because the y point, the y coordinate is at minus 28. And if we have any lines that are of y equals any value less than minus 28, then it does not cross or intersect with the curve. And so the set of values for which this and this do not meet or have no real roots is for y values that are less than minus 28. And we get 1 mark for that. Now part C is saying find the exact roots of the equation 9x squared minus 36x plus 8 is equal to minus 15. And I'm going to use the completed square form again for this part. So it's 9x minus 2 squared minus 28. And we're being told that this is equal to minus 15. So 9x minus 2 squared is equal to minus 15 plus 28. And this is 9x minus 2 squared is equal to 13. Right, and dividing by 9 on both sides, we get x minus 2 squared is equal to 13 over 9. And to get rid of this, we're going to introduce a square root side on both sides, and that gives us x minus 2 is equal to plus or minus root of 13 over 9, and x comes down to plus or minus root 13 over 9 plus 2. So the first value of x will be root 13 over 9 plus 2, and the other one will be minus root 13 over 9 plus 2. And since the question said the exact roots, we're not going to simplify the square roots. We're just going to leave our answers as this. Now, moving on to number 2, it's saying find the term independent of x. Independent means without, in this case. So we're looking for a term without x in the expansion of this, a term without x. So first of all, we don't know what we're going to choose from 6 to get a term without x, but we are going to use n for that. We're going to choose n and try and make n equation for 3 marks. And so we say 6, choose n. Then we start with the fraction, minus 3 over x. This is to the power n. Then our 2x squared to the power 6 minus n. Right? Now we're going to make an equation in terms of n, because we know that the term does not have x. So the powers of x should add up to 0. That's what we mean by a term independent of x. So to get that, you know, this x is in the denominator, this one. So this is like x to the power minus 1. And it's being multiplied by that n, like that. And this one, this is x squared raised to the power 6 minus n. So we're just going to deal with the powers of n and equate them to 0. So if we have this and that and this like that, we just say minus n plus 2 6 minus n is equal to 0, because we want a term without an x. So this will be minus n plus 12 minus 2n is equal to 0, giving us minus 3n plus 12 is equal to 0, and finally minus 3n being equal to minus 12. And this will give us minus 3 minus 3 to give us n is equal to 4. Now we know what to choose from 6. To get the term now, we're just going to go ahead with this to say from 6 we are choosing 4. And starting with our fraction, minus 3 over x to the power 4 and 2x squared to the power 6 minus 4, which is 2. Punching that in our calculators, 6 choose 4, get 15 times minus 3 to the power 4. Let me remove the minus. I think I punched it wrong. 3 to the power 4 there, because you know it's going to be positive. Let me do it again. 6 choose 4 times 3 to the power 4, 12, 15. Then times 2 squared, which is 4. I'm getting 4860. Then I have x to the power 4 for this part and x to the power 4 for this, and these two will cancel out, giving us a term independent of x, which is 4860. And that will be our answer for this one, to give us 3 marks. And number 3 is now saying on part A, the graph y equals f of x is transformed to the graph y equals f3 of x plus 2. Then it goes on to say, describe fully the two transformations which have been combined to give the resulting graph. And so for this, we're just going to compare the two given equations. The y is equal to f of x and y is equal to f3x plus 2. Now looking at these two, we can see two differences. One is this 3 and the second one is this 2, and those are our transformations. But now starting with this one, the one that's closest to the x, it is a stretch. It is a stretch, in the x direction, because the number is multiplying x, it is a stretch in the x direction. But the scale factor now of scale factor is this inverted, so it's 1/3. So for the stretch in the x direction, the scale factor is always the coefficient of x inverted. So in this case, the coefficient will be 1/3. But if we had something like this, where you have f then x/3, like so, plus 2, then the scale factor would be 3, because this is 1/3, and inverting it we get 3. So in this case, the scale factor is 3. And we're done with this part. Now this part, that is a translation in the y-axis of 2 units up, which we can also write as a vector 0, 2, like that. So with this vector, we just write translation by this, and we're done. But if you also want, you can write it is a vertical translation of 2 units upwards, a vertical translation of 2 units upwards, and you get your 3 marks for 3 part A. Now in part B, it says a different graph has equation y equals g of x. This graph is stretched by scale factor 3 in the y direction, then reflected in the y-axis. Write down the equation of the transformed graph in terms of the function g. Okay, so we have a scale factor 3 now in the y direction, and then a reflection in the y-axis. So for a scale factor 3 in the y direction, we just multiply our graph by the scale factor, which is 3. So that gives us y is equal to 3 times g of x, which is 3gx, like that. And for the reflection in the y-axis, we multiply the x part by -1. And so the resulting equation of the transformed graph will be y is equal to 3g minus x, like this. And it's also good to remember that for a reflection in the x-axis, we multiply the outer part by -1. So for reflection in the x-axis, it's the outer part which is multiplied by -1, and for reflection in the y-axis, it is the inner part, which is the x, that is multiplied by a -1. And so this becomes our answer for 3 part B, to gain us 2 marks. And so moving on to number 4, it says the equation of a curve is such that the dy dx is equal to kx to the power 3 plus 2 over x squared, where k is a constant, meaning k is just a number. The curve passes through the point S, which has coordinates 220, and the gradient of the curve at S is 65/2. Now for 1 mark, part A is saying find the value of k. And since we're told that the gradient at S is this, we're going to substitute the x with 2, which is the s coordinate for S, and that will be k 2 to the power 3 plus 2 over 2 squared, which is 4, and we're told this is equal to 65/2. And this will give us k, because 8k plus half, so just write it as 8k is equal to 65/2 minus half. And to get k, this is going to be divided by 8, and 65/2 minus 1/2 is 32. 32 divided by 8, we get our k to be 4. Now we equated this to this, right, dy dx to 65/2. Then we substituted x with 2, since 2 is the x coordinate of s. 2 is the x coordinate of s, that's why we substituted it in to the dy dx expression, and we equated it to 65/2. And for 1 mark, our k is equal to 4 there. Now on part B, it says the coordinates of a point t on the curve are 1t. Find the value of t, which is the y coordinate. And if we had the equation of the curve, we're just going to substitute this one into that equation to get the y part. But here we have dy dx, so we're going to integrate that expression for dy dx and try and get the equation of the curve. Then after that, we substitute x with 1 to get the y part. And so we have dy dx equals dy dx is equal to kx to the power 3 plus 2 over x squared, right? And we know that our k is 4. So write this as 4x to the power 3 plus 2 over x squared, which we can write as 2x to the power minus 2, like this. And so integrating this is our dy dx. We're going to integrate this. It gives us y is equal to, and for integration we add 1 to the power and we divide by the new power. So that will be 4x to the power 4 over 4. These will cancel out. Then 2x to the power minus 1, add 1 to the power over minus 1. And this comes down to x to the power 4 minus 2x to the power minus 1 plus a constant. Right? And for us to get this constant, we look for a point that's on the curve. And if we look at our question, we're given point S. And we're told that the curve passes through point S and the coordinates are 220. So at S, x is 2 and y is 20. So we're going to substitute those coordinates. So 20 for y is equal to 2 to the power 4 minus 2 to the power minus 1 plus c. And to get c, I'm just going to take this to the left hand side to get our c to be 20 minus 2 to the power 4 plus 2 to this is 1, it's 5. So our c is 5. So then our equation will be y is equal to x to the power 4 minus 2x to the power minus 1 plus 5. Now with this equation, we're just going to substitute this one to get the y coordinate. So substituting 1 in there, we get 1 minus 2 plus 5. And that gives us y is equal to 4. Therefore, we can safely say t is equal to 4. And we get our 5 marks for that. Now, for the fifth question, it says the equation of a curve is y equals 4x to the power half minus x. The curve is a maximum point when x is equal to a, which is this part right here, and crosses the x-axis at the point with coordinates b0, which is this coordinate right here, where b is greater than 0. Obviously, the shaded region is bounded by the curve. The line x is equal to a and the x-axis. Then it refers us to the diagram. Then part A is saying find the value of a. Now a is the x coordinate of the maximum point, if I'm not mistaken. Yes, it's the coordinate of the maximum point. And we know that at the maximum point or the minimum point, our dy dx is equal to 0. So we're just going to find dy dx for this, then we equate it to 0, and that is going to give us the x coordinate of the maximum point, which in this case is a. So dy dx of that, we get half times 4, then x to the power minus half minus 1. So this gives us 2x to the power minus half minus 1, and this is our dy dx. Right, then we equate this to 0 like so, and it will give us 2x to the power minus half is equal to 1. Then x to the power minus x to the power minus half is equal to half, and this is 1 over root x being equal to 1 over 2. 2 is equal to root x, and to get x we square both sides, and our x is equal to 4, like that. And we know that this x is equal to 4. The x is is a, which is the coordinate of the maximum point. So we can write a is equal to 4, and we get our 3 marks for 5 part A. And part B, for 5 marks, is saying find the exact area. We're not simplifying. Find the exact area of the shaded region. Let's look at the shaded region. The exact area of the shaded region. This is area under the curve with limits B and A. And you know A is 4. B, however, to find B, we know at B, y is 0. This y is 0. So we just equate this part of the curve to 0 to get B. And so 4x to the power half minus x, 4x to the power half minus x, is that correct? Yes, is equal to 0 because y is equal to 0. And then 4x to the power half is equal to x. Now this is 4 root x being equal to x. So if we divide both sides by root x, we get 4 being equal to x to the power half. Since this is x to the power half, it's like x to the power 1 over x to the power half. We know it will be x to the power 1 minus half, which is x to the power half. And for this, we just square it, square both sides. So 16 will be equal to x. And this is b. So b here is x is equal to 16. And we're going to use 16 and 4 as our limits while we integrate the curve to get the area under the curve with those limits. So we have y is equal to 4x to the power half minus x, like this, and integrating this part, we get 4x to the power half plus 1, that's 1 and a half, which is 3 over 2. Then we divide by the new power, 3 over 2, minus x to the power 1 plus 2, which is 2 over 2. And we're going to use our limits 16 for b and 4 for a, like that. And we can substitute our limits straight in. So this is 4 bracket 16 to the power 3 over 2 over 3 over 2 minus our 16 squared over 2. That is giving me 42 and 2/3. Then I subtract what I get after substituting 4. So I'm just going to replace my 16 with 4 in the calculator. 4, and it's giving me 13 and a third. So now our 42 and 2/3 minus 13 and a third gives us 29 and a third square units as the area of the shaded region. 29 and a third units, and we get our 5 marks. And moving on to number 6, says sketch the graph of y equals 3 sine x plus 2. Now sine graph generally goes from here through to put 1 and minus 1, goes from there, then 1.5, then this comes down to minus 1 here. Oops, no, it's here and here. And so if we join these points, let me try better, like this. And this is for y is equal to sine x. But as you can see, we have 2 transformations on this, and the first one being this 3. So 3 is multiplying the graph, meaning it's a stretch in the y-axis or stretch in the y direction. So it multiplies this, right? And if we multiply 1 by 3, we get up to 3. And if we multiply minus 1 by 3, we get down to minus 3. Now from there we have a vertical translation of 2 units up, again affecting the y-axis. So we're going to add 2. So to this 3 we're going to add 2 to get to 5. Let me put the 3 here. 3, we're going to add 2 to get to 5, and from this minus 3 adding 2 we get back to minus 1. So the bottom part of the graph is being limited to minus 1, and the top part is being extended to 5. And now from minus 1 3 to 5, it's 6 points. So we look for the third one. 1, 2, the third one will be a 2, and that's where we put our line like this to represent this one. We put it right in the middle. So now this point is now on 5, and this point remains on minus 1 like that. And I'm just going to rub this. Right, so we have this point, the point that was on 0, 0. If we multiply this by 3, it remains 0, but if we add 2, then it gets up to our 2, which is right there. So the point will be here now. And this, then we have a point that was here, right? If we multiply it by 3, it remains on there, but if we add 2, it gets up to this 2, following the transformations. And this was here, and this one, the point that was on 2 pi, if we multiply it by 3, it remains there, but if we add 2, it gets to this part. So those will be our new coordinates. So we're just left with joining them to get this. Oops, like this, and that will be our graph. Y is equal to 3 sine x plus 2, and you get 2 marks for that. So you can even rub this out to get that. Perfect. And moving on to part B, it says determine the number of solutions in the interval Now moving on to part B, it says determine the number of solutions in the interval from 0 to 2 pi of each of the following equations. The first one is 3 sine x plus 2 is equal to x. This is the graph that we've just sketched, and it's saying it's equal to x, meaning we have two graphs. Y is equal to 3 sine x and y is equal to x, and these two are being said to be equal. So if we draw y equals x, then we see how many times it crosses the graph that we have sketched. Y equals x is like this, pass through 0, 0, then 1, 1. Just assume it's somewhere here, and we extend it like that. We can see that it's only one solution, so 1 will be our answer for this. Then for this one, we can see this is the graph that we sketched, and we also have this one, meaning again we have two graphs. Y equals 3 sine x plus 2, and y is equal to 5 minus x. Now for the 5 minus x, you might want to draw a very simple table of values, that is if you have time, but I don't think we need it for this because we just need 2 points. When x is equal to 0, y equals 5, and when y equals 0, when x is equal to 0, y equals 5. When x is 0, y is 5, because we have y equals 5. And when y equals 0, x is also equal to 5. So when x equals to 0, y is at 5. And when y is equal to 0, this is equal to 5. So pi is 3,2. 3 over 2 pi will be somewhere close. It's 4,7. So it's somewhere here, the 5. So if we join these two, we can see that we have 1, 2, and 3 solutions. And so for this, it will be 3 number of solutions, the number of times this line is crossing the graph that we drew. And so 1 and 3 will be our answer to get those 2 marks. And part C saying solve the equation 3 plus sine x plus 2. 3 sine x plus 2 is equal to 5 cos squared x minus 1 for x taking values from 0 through to 2 pi. And for this, if we look at this two, there's really no easy way for us to change from sine x into anything with cos x. But however, we can change this cos squared to be in terms of sine x. And that's what we're going to try and do. So this becomes 3 sine x plus 2 is equal to 5. Now, cos squared in terms of sine squared, it's 1 minus sine squared x. And we write our minus 1 like that. Now, this becomes 3 sine x plus 2 is equal to 5 minus 5 sine squared x, and we subtract that 1, and we're going to take everything to the left hand side. So that becomes 5 sine squared x plus 3 sine x, then our 2 minus 5 plus 1. 2 minus 5, that's minus 3, plus 1, that's minus 2, is equal to 0, like this. Now with something like this, we can say let y be sine x, like that. And from there, we say 5y squared plus 3y minus 2 is equal to 0. Y is now standing in for sine x. Then with this, we can just solve it either using factorization or the quadratic formula. But looking at this, 5 times 2, that's 10. We can go ahead and use factorization. And that gives us 5y squared plus 5y minus 2y minus 2 is equal to 0. And that's 5y, y plus 1 minus 2y plus 1 is equal to 0. And this comes down to y plus 1 and our 5y minus 2 being equal to 0. And y is equal to minus 1, or y is equal to 2 over 5. We take this 2 to the other side and we divide by 5. But keep in mind that your y is standing in for sine x. So this is sine x is equal to minus 1, or sine x is equal to 2 over 5. Now I would want to refer to the graph that's up there for this, but let me see if it will make sense. Oh, this is transformed. It's not the graph for sine x. So I'll just go ahead and use the cast system. But for this minus 1, might need to refer to the graph for the explanation. Now, for this part, sine x is equal to minus 1. Let's look at the graph. It goes from 1 to minus 1. So whenever you get a trig function being equated to minus 1 or 1, it's always good to see if you can draw the graph and get your answer from there, because the sine graph will look like this, right? And as you can see, when the sine x is equal to minus 1, it's only at 270. When sine x is equal to minus 1, we get 270 degrees. And I find this easy because you're just looking at the graph. The sine x is minus 1, we have it at 270 degrees, and that's that. And for this part, we say x is equal to the sine inverse of 2 over 5, and that gives us sine inverse of 2 over 5. It's giving us x to be 23.6 degrees, like that. And this is our principal value that we have here, because this is the principal value, 180 minus the principal value, then 180 plus the principal value, 360 minus the principal value. Now for this, we can see that sine is positive because 2 over 5 is positive, and sine is positive in the first quadrant and the second quadrant. So we're going to take the principal value to be one of our answers, and to get the other answer we're just going to say 180 minus that minus the principal value, and that gives us 156,4. So our three answers will be 270, 156,4 and 23,6. And as you can see, these three answers fall within this. Oops, we are supposed to be dealing with radians because we have 2 pi there. So I'm just going to change all these into radians. So starting with this and the 270, so changing them to radians, just make sure my calculator is in radians. Then I say sine inverse of 2 over 5. I get my principal value to be 0.412 radians. Then 180, which is pi, I'm just going to say minus pi. I'm getting 2.73 radians. That's for this. Then for 270, it's 1.5 pi. So these will be our three answers. And moving on to number 7, it says the coordinates of the points P and Q are 1, 1 and 7, 11 respectively, meaning this is our P and this is our Q. Oops. Respectively, the line segment PQ forms a diameter of a circle, meaning these two are on the circumference of that circle. Then says find the equation of the circle. So if we have a Cartesian plane like this, then we are on 1, 1, then 7 and maybe 11 up here, then these two being part of a circle like this, and it's the diameter, meaning it passes through the center like that. To get the equation, we will get the center first. And why are we getting the center? We know the general form of the equation is x minus a squared plus y minus b squared is equal to r squared, and our a and b are the coordinates of the center. So we're going to try and get the coordinates of the center first, then we use the coordinates of the center and one of these points P and Q to get the r part. So in doing that, we can see that the center is the midpoint of the line segment PQ. So to get the midpoint, we add the x values, the x coordinates, then we divide by 2, then the y coordinates, then we also divide by 2. That is 8 over 2, which comes down to 4, then 12 over 2, which is 6. So our center, which we can call O, is at 4, 6. So then our equation will be x minus 4 squared plus y minus 6 squared is equal to, then for r squared, we're just going to use P, which is 1, 1, and our center O, which is 4, 6. Then we're going to get the distance between these two, and that will be our radius, because it will be this distance. And for this, we're going to use the formula d is equal to the square root of x2 minus x1 squared plus y2 minus y1, like this. So we might want to name our coordinates. This will be x1, y1, then x2, y2. Now we're just going to substitute those. So our d will be equal to square root of our x2 is 4 minus x1, which is 1, squared, plus our y2 is 6 minus our y1, which is 1, squared. And punching this into our calculator, we get 4 minus 1, that's 3, squared, that's 9. We do it again, square root of 9 minus 5 squared, that's 25. So root of 9 plus 25 plus 9 plus 25, 34, root 34. And this is our radius. But if we get back to this, we want r squared. So if our radius is this. R squared is that squared, which is 34, and this will be it. And this will be our final answer for the 4 marks. Moving on to part B, says find the equation of the tangent to the circle at point Q. And if this is our P and this is our Q, we're being asked to look for the tangent at Q, which is a line that touches the circle at Q. Let me rub this. Right. And to get the equation of a tangent, firstly we need the point Q, which we're given, and after the point we need the gradient. So for the gradient of the tangent, we're going to start by calculating the gradient of this radius. Then we use it to get the gradient of the tangent. After we get the gradient of the tangent, we use the point Q to get the equation. So to get the gradient of the radius, we have point O, which is at 4, 6, and Q, which is 7, 11. 4, 6, and 7, 11, like that. Right. And to get M, I like naming coordinates. So this will be your x2, y2. Now M is y2 minus y1 over x2 minus x1. And this will be our 11 minus y1, which is 6, over our x2, which is our 7, minus 4. And this gives me 5 over 3. Now we know that the radius meets the tangent at a right angle like that. And if we have lines that are perpendicular to each other, meaning lines that make a 90-degree angle when they meet, the gradient of one of the lines times that of another is supposed to give you -1. And in this case, the other line is our tangent. So if we have the gradient of 5 over 3 times the gradient of a tangent, which we can call t, being supposed to give us -1, we can get t to be -3 over 5. And t is standing in for the gradient of the tangent. Now with the gradient of the tangent and the point Q, which is right here, 7 and 11, we can get the equation. We just use y minus y1 is equal to mx minus our x1. Now y minus the y part of Q11 is equal to m, our minus 3 over 5, x minus our x coordinate 7, like that. And multiplying that, we get y is equal to minus 3 over 5x plus 21 over 5 plus 11. And 21 over 5 plus 11 plus 11. That's y is equal to minus 3 over 5x plus 15 and a fifth, like that. And that would be the equation of the tangent at Q. That gives us 3 marks. And now for part C, says the other point on the circle with x coordinate 7 is R, meaning R has coordinates 7 and y. Says find the coordinates of the point of intersection of the tangent at Q with the tangent at R. The coordinates of the point of intersection of the tangent at Q and the tangent at R. Tangent at R, so the other coordinate where x is equal to 7. So x is equal to 7 goes like this, meaning if we have Q being at x equals to 7, the other point at x equals 7 will be right here. And we want the coordinates where the tangent at this point meets the tangent D. We can call it W, like that. That's what we are looking for. So we're going to need to have the equation of this other tangent, then you equate it to the equation of that tangent that we've just calculated. And it's good to also understand that the gradient of this and the gradient of this are just, if this is, let's say 1, this will be -1. So the gradient of this other tangent is just the negative of the gradient that we calculated earlier. Here we found the gradient to be -3 over 5. So the gradient of the tangent passing through R, the gradient is going to be, and for the equation of the tangent, again we're going to use y minus y1 is equal to mx minus x1. Now y minus the y coordinate, which is 1, is equal to m3/5 x minus the x coordinate, which is 7. And this gives us y is equal to 3/5 x minus 21/5 plus 1. Then minus 21/5 plus 1 is giving us minus 16/5. So this is y is equal to minus 16/5. Y is equal to 3/5x minus 16/5. Now to get the coordinates of the point of intersection, I'm just going to equate this to this right here. So our 3/5x minus 16/5 is equal to minus 3/5x plus 76/5, like this. And so 3/5 plus 3/5 plus 3/5, I'm getting 1 1/5 x. I took this to the other side, should give us 76/5 plus 16/5, which is 18 2/5. And dividing by 1/5, I get x to be 18 2/5 divided by 1/5. It's giving me 15 1/3. And to get the y coordinate now, I'm just going to substitute this into this equation right here. So 3/5, our x is 15 1/3 minus our 16/5. Then I'm getting the y coordinate to be 6. So that point, which we called w, is coordinates 15 1/3 and 6, like that. And this is for 4 marks. And now on to number 8. It says the first 3 terms of a geometric progression are a, b, and c respectively, where a, b, and c are positive constants. The first 3 terms of an arithmetic progression are a, b, and minus 3c respectively. It says for a, show that a squared minus 10ac plus 9c squared is equal to 0. Now, since we are told that the first 3 terms of a GP are a, b, and c, we know that for GPs, geometric progressions, we have a constant ratio, which we get by saying the second term, which in this case is b, over the first term. And I said it's constant, so it's the same. So this is equal to the third term over the second term as well. And for the AP, we have a, b, and minus 3c. And for AP, we have a common and for the AP, we have a common difference. We have a common difference d, which we get by saying the second term b minus the first. And I said it's constant and it's common, so minus 3c, which is the third, minus the second, is supposed to give us the same answer, like this. Now with this, you can see that we get 2b. If we take this negative b to the left hand side, 2b plus 3c is equal to a, right? But if we look at this, a squared minus 10ac plus 9c squared, we can see that we do not have a b. So I'm going to try and make b the subject here. So 2b is equal to a minus 3c, and b is equal to a minus 3c. Why did I write 3b here? Made a mistake. It's a minus 3c. So it's a minus 3c over 2. Now I'm going to substitute this expression for b into here, right? It's b over a is equal to c over b. So b, which is a minus 3c over 2 over a, is equal to c over b, which is a minus 3c over 2, like this. And this will give us, let me just move this to the other side, right? This will come to be a minus 3c over 2a is equal to 2c over a minus 3c. I was just doing this multiplies that and becomes the new denominator, but this multiplies this and this becomes the new denominator. So it's like having 3 over 1/3. This goes to multiply this and this becomes the new denominator. But if we have a third over 3, this just multiplies that and we have a new fraction with this as the numerator and this as the denominator. That's what I did there to get this. And cross multiplying, I get a minus 3c. A minus 3c is equal to 4ac. So this gives me a squared minus 3ac minus 3ac plus 9c squared is equal to 4ac. And this comes down to be a squared minus 6ac, taking this 4ac to this side, the left hand side becomes minus 4ac plus 9c squared is equal to 0. And this finally gives us a squared minus 10ac plus 9c squared is equal to 0, like that. And this is the exact expression we're given there for part A. And now move on to part B. It says it is now given that a is 9 and c takes the smaller of the two possible values. It is given that a is 9 and c takes the smaller of the two possible values. Then B part 1 says find the sum to infinity of the geometric progression. So taking a to be 9, we're just going to substitute 9 for a on this equation. So then that will be 9 squared, which is 81, minus 10 times 9, which is 90c, plus 9c squared is equal to 0. And that gives us a quadratic. I'm just going to use the quadratic formula to get the two values of c. So we know it's minus b, which is minus 90 plus root of b squared, which is 90 squared minus 4. A is 9 and c is 81 over 2a, which is 29. And the first one is 9, the second one is, let me just replace the positive with the negative, it's 1. Remember, this is our a, this is our b, and this is our c. And the question tells us that c takes the smaller of the two values, so c is 1. So with c is 1, we have a being 9, c being equal to 1. And if we look at this expression for b, it says a minus 3c over 2. Now a is 9, so that's 9 minus 3 over 2, which is giving me 3. So b is 3. Now to get the sum to infinity of a geometric progression, we can start by stating the formula a over 1 minus r, where r is the common ratio. So to find it, we say a over b. So it's b over a, second over first or third over second. So that's 3 over 9, which gives us a third, like that. And our a is 9, so this will be 9 over 1 minus a third, which comes on to be 9 over 2/3, which gives us 27 over 2 to be the sum to infinity, and that is for 5 marks. Now on to the second part. It says find the sum of the first 20 terms of the arithmetic progression. So we're just going to use the same values, a9 c1 b3, a9 c1 b is 3. But for the AP, there was something different. a, b, and minus 3c. We're saying a, b, and minus 3c. So the first term was 9, b is 3, and this is minus 3c, which is minus 3. And so we get d to be 3 minus 9, which is minus 6, which we can also get by saying minus 3 minus 3 to get minus 6. Now for the sum of the first 20 terms, we get the formula. It states that Sn over 2, then 2a plus n minus 1, the d. So since we know that it's sum of 20, just going to say 20 over 2, then 2a, which is our 18, plus n, that's 20, minus 1, that's 19. So it's 19, and our difference is minus 6, like this. So this is 10, 18, then 19 times 6, we get minus 114. So 18 minus 114 times 10 is equal to minus 960, and that will be our answer for the sum of the first 20 terms for 3 marks. Right, then for number 9, it says the function f is defined by f of x being equal to 4 over 3x minus 6 squared plus 1 over 3x minus 6 cubed, for x being greater than 2. That's our domain. And A is saying find an expression for f prime of x, and hence determine whether f is an increasing function, a decreasing function, or neither. So it's good to understand that f prime of x is the derivative of f of x. So for us to get the derivative there, we're just going to rewrite this first into this form, where we put 4 3x minus 6 plus 3x minus 6 to the power minus 3. It's easier to differentiate this way. And differentiating this, we get minus 2 times 4 times the derivative of this. So this minus 2, multiply that. I'm just going to multiply by the derivative of that for bracket 3x minus 6. Then I subtract 1 from the power. Then I do the same with this to say plus, oops, before I put the plus, minus 3 times 3, then the bracket 3x minus 6, then I subtract 1 from there to get minus 4. And this comes down to be minus 8 times 3 minus 24, 3x minus 6 to the power minus 3, minus 9, 3x minus 6 to the power minus 4, like this. And this is our f prime of x expression, right? That's the first part. And it says hence determine whether f is an increasing function, a decreasing function, or neither. And for that, we know that when the f prime of x is greater than 0, we can say the function is increasing. And if it's less than 0, then you say it's decreasing. But for us to get the answer to the f prime of x that we're going to compare with 0, we are going to substitute a value that is within this domain, right? So x is greater than 2, we're just going to pick 3 as a number that is greater than 2, and we're going to substitute it into this. And if we get a value that is greater than 0, we know it's increasing. Less than 0, we know it's decreasing. So substituting 3 there, we get minus 24. That's 3 times 3, 9, minus 6. That's 3 to the power minus 3, minus 9, 3, and 3 minus 6 to the power minus 4. And I'm getting minus 1. And as you can see, minus 1 is less than 0. So we can safely say this is a decreasing function. Then we get our 4 marks for 9 part A. For B, which is saying state whether an inverse of f exists and give a reason for your answer. And it's for 1 mark. So looking at the previous question, we determined that it's a decreasing function. Now, if it's a decreasing function and we are convinced that it's strictly a decreasing function, then that means each x coordinate is going to give us a unique y value, and that is going to be my reasoning for this, to say that f inverse exists, and my reasoning is it is strictly decreasing, and this means that we don't have one x value giving us multiple y results. So if I say it is strictly decreasing like this, I can then say therefore it is a 1-to-1 function, like so. And that would be my reasoning for that 1 mark. And for part C, says the function g is defined by g of x being equal to 4x minus 3 for x being greater than a, and says find the range of g in terms of the constant a. And so for this, I'm just going to substitute this a into this expression for g of x. So that would be 4a minus 3. And if x is going to take only the values that are greater than this a, that tells me that this g of x, the range of g of x rather, will always be greater than this, because I know that all the values that a is going to take, x is going to take values that are always greater than a. For example, if I take this a to be 2, let's say x is greater than 2, like this. So this would be 4, 2 minus 3, which is 5. And if I'm going to pick any other values that are greater than 2, I'll get a result that is greater than 5. Let's test it. If I pick 3, it will be 4, 3 minus 3. That's 12 minus 3, which is 9. And that's why I say g of x is greater than 4a minus 3. And this again is for 1 mark. Then D is saying find the set of values of a for which the composite function fg exists. And for fg to exist, the range of the inner function should be within the domain of the outer. So range of inner function, in this case the inner function is g, should be within the domain of the outer, function, which is f, like this. And the range of inner function is this right here, 4a minus 3, and we're saying this should be within the domain of the outer function. The domain of f is given here as x is greater than 2. It's given by x is greater than 2. So this has to be within this, meaning 4a minus 3 should be greater than 2 for it to be within this. This has to be greater than 2. And so then we just solve this. 4a is greater than 2 plus 3, and a will be this divided by 4. A is equal to 2 plus 3, that's 5 over 4, and I put equal there by mistake. So this is the set of values of a for which the composite function exists, and that gives us 2 marks. 10, we're given a diagram, and it says the diagram shows a circle with center a. A is right over here, a, and radius r. You can see the r values there, and it says passing through points B, C, and D. A larger circle of radius S is center C, this big one, and passes through B and D, and it says the length BD is also S. Then part A goes on to say show that S is equal to root 3r. This is like us being asked to express S in terms of r. So I'm just going to try and look for a relationship here. So if we look at this, angles about A are 360 degrees. But before we get onto using degrees, let's just try and find evidence of, yes, there is a pi, meaning we're dealing with radians. But there were better ways to do that. We're dealing with radians, so angles about A are 2 pi radians. So these are making 3 equal angles. As you can see there, those are 3 equal angles. So we divided by 3. Each one of the angles is 2/3 pi, like that. Let me just rub this. So my thinking is, if we divide it into half to form right angle triangles, we also divide the angles into half. So if we have 2/3 pi divided by 2, we just multiply the denominator by 2 to be 2/6, which is a third. So now we have a third pi, we have r, and we have half s here, but let's call it x, but we know x is half of s. Now we can use our trig functions to say this is opposite this angle and this is the hypotenuse. So we could say sine a third pi is equal to the opposite x over the hypotenuse r. So then x will be r sine a third pi, like that, and this comes down to be sine r, let me make sure my calculator is in radians, sine a third pi, it's giving me √3/2, like this. But we know that x is half of s, right? So x times 2 is s, so we're just going to multiply that by 2, √3r/2 times 2, and we get √3r is our answer. So you can just put the work in here to get your 2 marks. Alright, to part B, it says find an expression for the area of the shaded region. Give your answer in the form a plus b pi r squared, where a and b are constants to be found, and that's for 7 marks. So we're going to look for an expression for the shaded region, for the area of the shaded region. So I'm just going to rub this. Right, so we want an expression for the area of the shaded region. So usually when we're dealing with area, we normally say area of the whole shape minus area of the unshaded to get the area of the shaded part. So here I'm just trying to see which one we can call our whole shape and which one we can call our unshaded. So if we look at this, we could say this is our area of whole shape, right? Area of whole shape, and from there we subtract area of unshaded, which is this in red, to get area of the shaded. And again, I think I'm going to use this part so that I can refer to the diagram. So we're going to say area of whole shape minus area of unshaded part, area of the unshaded part. Right, now for the area of whole shape, if we look closely, we can see that it's made up of this sector. Oops, this is the area of the unshaded. For the area of the whole shape, we are saying it's made up of, now for the area of the whole shape, we can see it's made up of this sector of the smaller circle and this triangle, these two triangles, and that'll give us area of the whole shape. So this angle, like we said, it's 2/3 pi and the radius is r. So to get area of that sector, area of sector, we're just going to use our half r squared theta, and it'll be half, our r is r, so r squared, but our theta is 2 over 3 pi, like that. That's going to give us r squared pi over 3. Right, then for these two triangles, we're just going to calculate the area of one and multiply it by 2. Again, the angle is 2 over 3 pi, and this side is r, this is r. We're just going to use, let's write area of triangle. We're going to use half AB sine theta, and AB being the two sides that make up the angle. So they're both r, so I'm just going to say half r squared, then sine 2 over 3 pi, like that. Sine 2 over 3 pi, sine 2 over 3 pi. I'm getting root 3 over 2. So this is half r squared root 3 over 2. That gives me root 3 r squared over 4, like that. And to get the area of these two triangles, I'm just going to multiply that by 2. So you need to be writing the narrations down. The area of the two small triangles is now equal to that, which is this divided by 2. So that will give us root 3 r squared over 2. Now we're just going to add this and that for the area of the whole shape. So that's r squared pi over 3 plus r squared root 3 over 2, like that. This is the area of the whole shape. Now for the area of the unshaded, the area of the unshaded part, this one is simpler because it's just a sector of the bigger circle. And if we say these are 2/3 pi each, to make pi, which is 180 for the triangle, we need this and that to make up the remaining third pi. And if we divide it by 2, it will be 1 over 6 pi for each one of these. 1 over 6 pi. So to get this angle, it's 1 over 6 pi times 2, which gives us a third pi. And the radius is s. So for the area of unshaded, we're just going to say half r squared. Let me just write the narration. Use screen. Area of unshaded. Then I say half r squared theta. That will be half s squared. The theta is a third pi, like that. But remember, from part A, we expressed s in terms of r. So in place of s, I'm going to use root 3r. So that's half root 3r squared, then a third pi, like so. And that will be half being multiplied by 3r squared multiplied by a third pi, like this. And this gives us r squared pi over 2. R squared pi over 2. So now I'm just going to say this area of whole shape minus area of unshaded. So down here, I'm just going to say area of whole shape minus area of unshaded. In our case, according to our working, r squared pi over 3, r squared pi over 3 plus r squared root 3 over 2 plus r squared root 3 over 2. Let me just check. Yes, minus r squared pi over 2 minus r squared pi over 2. So these two are common and can subtract each other. So with a third subtracting a half, and that gives us minus 1 over 6 r squared pi, this third minus this half, and we have r squared root 3 over 2 remaining. Now if we look at this, we are factoring out r squared. So factoring out r squared there, we get r squared, then root 3 over 2 minus a 6 pi, like that. And so our a will be root 3 over 2, and our b will be minus 1 over 6, and then our pi there, and this will be our answer in that form for 7 marks. I hope it was clear enough. And that brings us to the end of this paper. Thank you guys for joining me. Please do consider subscribing if you're finding any of this helpful.